Hi, today I'm gonna start to talk about a free body diagram and how we are gonna use it later on when we want to analyze any object in statics. So the topic is gonna be the free body diagram. When we are talking about the free body diagram, what we mean is that we want to take any object that sits anywhere and take it out, disconnect it from whatever is connected to that, and then apply forces to that object for purpose of analysis. So how we are going to do that? We know that any object that we have that is in rest, there are some forces that want to move it and some forces that keep it in the place. Assuming a chair sitting on the floor, so if that chair has a gravity, that gravity want to pull it down. So it's a force that wants to make it to move. And there's a support between the chair leg and the ground which support the chair and doesn't let it to move. And those are the support forces that keeps it in the place. All those forces are external forces, that some of them are active forces that want to make it to move, and then some of the forces are the support forces that want to keep the object in its place. And eventually they have a balance if the object is not moving, there's a balance between the forces that wants it to move or push it into the motion, and the forces that wants to keep it in the place and doesn't let it move. Before I start to show how we are going to do the free body diagram, there are three types of support that I'm going to talk about that right now. There are other type of support that we talk about it later on. One of the first type of the support that I'm going to talk about is the spring. If an object is connected to the spring and the spring holds it in place. So how the springs work? If you have a spring like that, and it has a initial length of a knot, and then if we apply a force on that, and that force can be tension or it can be pressure. So either way of the forces, we can pull it apart or we can push it. It doesn't matter. It's going to be the same way. So here I just show for the pulling it apart as a tension, but if we pushing and compacting is exactly the same thing. So assume there's a force here that pulling it apart, and now we have the L, and it is become L. If we consider that the delta L is going to be the L minus also, so it's going to be a deformation respect to the time that is sitting at rest, so it hasn't deformed. So basically delta L just shows a deformation in a spring. In that case, if we have such a then F is going to be K delta L, which the K is a constant, show the stiffness of the spring, and delta is the deformation of the spring, and the forces apply on the spring to pull it away or push it toward each other. So that's going to be the forces. So that's the very first type we might have as a support. So an object is hold to the string and the string hold it in place. The other type of object that might hold an object, the other type of support that might hold an object in place is a rope or cord or anything similar to that. So if you have a cord, there are a couple of points that we have to consider about them. So assume we have a pulley that's sitting there, and then there's a cord going around that. So assume it goes, for example, here going vertically, goes around that and comes down like that. So assume we have the cord like this, and If you have a force on this end, it's going to be T. We pull it by T, then there's going to be the exact same T here. So if it's T on one end, it's going to be T in the other end as well. So they're going to be always the same. So when we're working in this course with the rope, there are 4 points that I want to mention. We always consider those 4 points. The very first point is that we consider there's no weight for the cord. The cord is it doesn't have any weight. So it's the very first point. The second one is that it's not a stretch. It's not gonna deform. So the rope does not deform. The third is that it only can tolerate or resist to the tension. We cannot push it, or we cannot put the lateral force on that. It only resists or tolerate the when we are pulling it apart, or tension. So it's the tension pulling apart force. And the last force, that if you look at here, the tension is always along the rope direction. So here is vertical, so the tension is vertical. Here it has an angle, so the tension has the same angle. So the tension is always along the rope. So these are the 4 points that we need to consider when we are working with ropes. And the very last form of support is that. So the first one was if the spring hold the support in place. The second one is if the rope holding the place. And the third one is that if an object lay or sitting on the surface. So I'm going to put it down here. Assume if you have an object sitting on the surface, and just any surface. If an object sitting here, assume the object sits there. I have an object sitting there, and this is the surface. If the object sitting on the surface, the force, the support force from the surface is always normal to that surface. So whatever support that force, that surface provide, is always normal to the surface. So if I consider it like that, there's a support that keep that object in a place. That support is always normal or perpendicular to that surface. So these are the 3 type of support we are going to work with that. And a string and a string can keep the object in a place, or a rope can hold in the place, or is sitting on top of a surface. So these 3. Later on, we will talk about the other types of objects. Now, let's go back to how we are working with the free body diagram. So when we want to talk at the beginning, when I was talking about the free body diagrams, that we had an object, that there are some forces that want to make it move, particularly the weight. It just wants to make it move. And there are forces that wants to hold it in a place and resist any motion. So the first one that want to make it move is the active forces. The second types of force that want to hold it in the place are reactive forces. How we are drawing a free body diagram? When we want to draw a free body diagram, we disconnect an object from any support it has and bring it like it is suspended in air. So we disconnect the object from any connection, nothing connected to that. Then we put all the external forces on that object. What are the external forces? First, the forces that want to make it move, like the weight, which call it the active forces. So the first type of external forces are the forces that want to make an object move. So we put all those forces on that. Then we put the second type of external forces, which are the forces that want to hold the object in a place, which are the supports. Any supports which have that hold in place, we put in there. So one more time, before we have 2 types of external forces: the forces that want to make the object move and the forces that want to hold it in place. So we want to draw the free body diagram. We disconnect that object from anything connected to that. Then we put all the forces that want to make that object moves, and then we put all the forces that want to hold that object in a place. This is a free body diagram. Now let's look at an example to show how we draw a free body diagram. Assume we had an object like this that is sitting on the surface. So there's a surface here. So that object sitting on that surface. And it's also connected by the rope to, there's a wall here. So it's connected by the rope to, like that. So it's connected, goes up, then goes there. And there's a pulley here. So it's connected by the rope as that. So we have an object that, and assume this is a 30 degrees. We have an object like that, which is connected by the rope and sitting on the surface. And I want to draw the free body diagram for that object. So the very first step is that we are gonna to disconnect that object from any support or anything that's connected to that. So the only thing is gonna be is the object itself. So nothing connected to that, nothing holding the place, nothing. It's just an object. That's the very first step. The second step, we are gonna draw the forces that want to make it move. Here, for example, the only force that want to make it move is its weight. So its weight wants to make it move. Then we are gonna draw the forces that hold it in a place. What are the forces that hold that particle in a place? So we have two forces holding in a place. One of them is the support from the surface. And if you remember, I told you this forces that if an object lie on the surface, sits on the surface, then the support is going to be normal to that surface. So we have the forces like that hold that object in a place, and because it's normal to that surface, this angle is going to be 30 degrees. And then another forces that want to hold it in a place is the tension in that rope. That rope also hold it in a place. Also, we have the tension in that rope. So this is the object we all support, and this is gonna be the free body diagram. So this is the free body diagram. This is the object itself. So the steps that we have, and one more time, say we disconnect the object from anything that hold it in place, and then we put all the external forces on that object. Our external forces are the active forces. Here is the weight, the forces that want to make it move, and then reactive forces, the forces that want to hold it in place, which is here is the tension in the rope and the support by that surface. Here object sitting on that. This is how we are gonna draw the free body diagram.